Okay, in this video we're going to take a look at how to graph a basic logarithmic function. Like basically take the meaning of this function and put it to a picture so that we can see what's happening over time, maybe at some extreme values, way to the left or way to the right. Now before we do that, I'm going to do something here that's going to probably make a few of you very uncomfortable. I'm going to take this y, we usually write on the left, and I am going to put it over on the right. Now I haven't changed anything. Just some of you don't like to look at it like that. But all I've done is move the y over there. And the reason I've done that now is this looks a lot like what I've been working with and interpreting for the past few days. Okay, I can rewrite this as 2 to the y power equals x. That's exponential form. And this is how our brain usually interprets these things for most people. So here's what I'm going to do. We always pick a few values to start with, and in this case, instead of picking x values, I'm going to pick some y values because it's something I can calculate pretty easily. Okay, I'm going to pick -1, 0, 1, 2, and 3. I just picked, a few of them there that I can calculate simply in my head. Now, why did I pick y values? Because if I think about it in this format, rather than the top one, keep in mind they mean the same thing, I could do these calculations easily in my head, and y would be the input in this case that would make this simple for me. Okay, it's not the only way to do this, it's just one way of thinking about it. So let's take a look at what happens here. If I put -1 in, 2 to the -1 equals, we want to know what x value comes out of that. What does that equal? Well, that's the same as flipping this over and getting 1 over 2 to the first, which is 1/2. So 1/2 goes right here. Now I'm going to do the same thing with 0. 2 to the 0 equals 1. 1 goes there. 2 to the first equals 2. 2 goes here. 2 to the second equals 4. 4 goes here. Notice this is not growing at a nice linear constant rate. 2 to the third equals 8. 8 goes right here. Now let's flip back to our mindset of x first, y second, our coordinates, and put where these locations would be. Okay, so 8, we'll start with 8, 3. 8, 3 is going to be somewhere over here. Now I'm going to go to 4, 2. 4, 2, somewhere in this realm. 2, 1, somewhere right about there. 1, 0. So 1 on the x-axis, 0 on the y. Going to be right on here somewhere. And our last one says 1/2 -1. So we're going to be somewhere right about here. Now notice, no matter what I do, no matter what I put in right here, this value is never ever, the x-coordinate is never ever going to get negative in this case. I can never get, it just keeps getting to be a real tiny fraction, but it never actually crosses over that line of 0. So what I have is a vertical asymptote that gets really close to the y-axis here, and then it sort of curves out and continues to get bigger and go up, but it's kind of, it flattens out a bit. It doesn't grow as fast as it was early on. And that is the general shape of a logarithm. Now, if you were to add some other numbers in here, you might be able to take this shape and move it around, or put in a negative sign and flip it over, but it has the same general look to it every single time. So that's how we graph a basic logarithmic function. It takes a bit of creativity to first make it look like this, and then turn it into something that our brain can sort of manipulate and handle those values in, and then pick some easy numbers, okay, like we always do, but in this case we pick them for y. We make y the input, and it's much easier to interpret what's happening.